Hey, just wanted to check if you guys can hear me or not. We will start in a couple of minutes. Um, Hey, yeah. So thanks for the few people who have joined in. So what I just wanted to kind of discuss on a high level is what are we, what is all things AI? Why are we trying to create this, and why is it even necessary to probably like have a small meetup around this? So I think the last 1 year, there's been a lot of stuff that's been happening around the ASPs, and like I've been like quite excited about since last November. I think what Stable Diffusion came out, and even DALI, what were the updates they had over the last 1 year. I think there's been some crazy stuff that's been happening there, and a couple of us have been actually looking into this more seriously, and we wanted to have a place where we could talk more about it, right? So this is one of the major reasons we wanted to create a community or a group around this. This is probably our first community, first meetup also. So you will see a lot of amateur behavior from our side probably, but we do have a lot of experience teaching. We do a lot of experience taking sessions as such. So we still want to conduct something called Learn in Public, where we are also learning with you folks, maybe through different people, and that's what we want to try here. In the future, we want to have more kind of people coming on with us and kind of sharing knowledge through this group. I think that'll be super interesting to see. So, like a few things which I can probably give you an idea is right now we have two members who are basically organizing things for us. One is Lohit. He's on the chat box also helping. He's been like super enthused about the AI space, and we've been having a lot of conversation for the last 5-6 months around this. We wanted to conduct this almost 3 months back, 4 months back, but I think we finally put a date on it, and then we said we'll do it today. So it's almost a couple of months of planning and figuring out what to conduct in this workshop. I've worked with Loth, I think, for a couple of years at our previous organization, and we've been building a lot of stuff around AI, and I think that's been a very interesting for us journey. And we're also now like moving into or getting into this space as a full time also. What I mean by that is we are actively like building and probably building products around this. So it's going to be a quite an interesting couple of years going ahead, right? So what what we want to do over here is we want to talk about something called Stable Diffusion, and we want to talk about something called image generation using AI, right? So I think most people are already quite maybe aware of what ChatGPT does or similar systems out there. This is on some or similar lines. It has that, right? Just give me a second. Yeah. So on some levels, it has that same layer, but it's a little different because I think we're working with images here, which is a little more different than just working with chat. So what is the outcome of today's session, or what we call as a session? It could be a small meetup, small conversation, discussion as such. What I want you to go back with this is probably a better understanding of what Stable Diffusion is, what you can do to run it, and probably how the prompts work, and probably maybe create some images and understand some of the ecosystem around it, right? One of the challenges around using Stable Diffusion easily is that you probably need a good system to run it. To be honest, like I haven't run it on my own system, so I run it on the cloud, right? So I'm not actually running it on my own system. So I'll show you a lot of examples on how you can get started with also. So what is a Stable Diffusion? Well, this is actually quite an interesting model which has come across over the last 3-4 years. And basically, if you look at the term, right, it says stable, and then there's something called diffusion. So there is a diffusion model which is basically working over here, and a stable version of that is able to create images for you, right, on a high level. This is an example of how they would explain the architecture. We won't be getting into this a lot because I think if we get too much into this could be itself, I could talk about it for probably a couple of hours. We don't want to get too much into this, but I'll give you probably a high level understanding of what really happens in this whole workflow, right? So when you input a mess or a prompt here, or we call it a prompt or a text, what you're seeing is like a painting of New York by Van Gogh. So what you're asking for is a painting, the subject, right, and of New York, right? It's a city. You're giving it some information, right? And you're also giving it a style, saying it has to be in this format of this Van Gogh. And there's a lot of things that happens in between this model here, which I'm not getting in too much in detail right now. But what you get out of it is a generated image. And this is when this came out, like I was crazy about this, right? Like I've been following this almost a year now, and I think it's great to talk about it and take probably an online session about it. But there's a lot of stuff that happens on the background, and just so you know, a lot of updates to this are happening every week or every day. So maybe in the next year you will see a lot more updates happening to the entire ecosystem. So how does this ML model, how does this training work? I'm going to give you a very simple high level model, right? So there is something called, so let's say you have an image, right? In this case, you can see this flower which is there. What we end up doing is that we add noise to it, which is what you see, this black color and white color, pixels on top of it, right? So we add this noise in different steps onto this, and we kind of train our model or train our system saying that, you know what, this image becomes this noise over this time, and maybe over 10, 15, 20, 100 steps as such, right? The newer models, it's lower number of steps, but essentially this is what is being trained into the system. And we also keep a text saying that this is a flower, right? I don't know the flower name, but let's assume this is a flower, right? And now there is a text embedding which is telling that, hey, this is related to this image also, right? Now this is the training piece of it. Now what happens is that when you want to create an image out of it, right, we do a reverse process of this. So instead of like adding noise to it, we now take a noised image and we remove noise from it. And when we do this over 20 or 30 different steps, or maybe 100 steps, at each level, right, we remove a little bit of noise, and then we compare, saying that, hey, is this kind of the output I want? And if there's too much of a difference between that, we try to go and add or remove noise again and again to get that final output that we need, right? So think of it this way. You have now, so your input comes from this noise now, and then now you're trying to denoise it, right? And then you finally get that output back. So this is a small example of how you can think of how the noise gets added and then how we are doing the denoising also, right? And this is why it happens through multiple steps. And you cannot do this in one single step because based on a lot of the research papers, what people have written, the output quality is much better when you have more number of steps involved, right? Now, there's a lot of different research papers around this. You should read some of the ones by OpenAI. They also have they have discussed a much faster way of denoising using cosine approach, where the gradual, like the adding noise is more gradual in nature rather than very exponential format, right? So that actually gave a lot better output for them also, right? So we're not getting too much into the core piece of it because we're here right now trying to see how can we use it. Once you understand how you can use the system, you'll probably have a better idea on how the system works probably internally later. So the outcome of the session is, again, you guys should probably be able to say that, hey, I know what the tool is and I can probably change this and play around with it and get some outputs out of it. Right. So this simplified workflow that we just talked about, let's assume this is the core stable diffusion model, right? This is the core piece. And how do we interact with it? How do we work with it? Well, we need a user interface, right? So this is where a lot of open source systems are available, right? Which actually use or built on top of this and run this on the background, let's say, or their own diffusion models, right? So a very common one is called automatic 1111. This is used, I also use this in today's workshop or today's session. We will be using automatic 1111. There is another newer system which has come out quite recently. It's called Comfy UI. This is a node-based system. It's got a lot, like, very interesting for people who are programmers probably and who want to automate a lot of things. I think they would probably like Comfy UI, but the learning curve is a little more, I think, over there. But I think for if you're looking at maybe automating a lot of stuff, I think Comfy UI makes a lot more sense. It's also a little faster in some certain models where you can faster than automatic 111 also. So it might make sense if you don't have a graphic card. One important note, you may be able to run automatic 11111 locally, but the challenge is probably your graphic card, or if your system is not able to support it, this could be a problem, right? So generally for processing, you probably need NVIDIA graphic card or some kind of a virtual RAM to kind of do these processing for you. Right. The other ones which are available are something called Dream Studio. This is by Stability AI. This is by the same company who's actually open source some of these models for everyone in the world. There's Invoke AI also, just another example which you can look into, right? All right. And what we're going to set up today right now is basically using automatic one. What I have right now is an online instance, right? So this is what it should look like, right? This is how it should look like when you run it. Now I'm going to show you the basic GitHub repository. I can skip this now. Yeah, so if you know what GitHub is and you want to run it locally, you can go through this. This has all the information on setting up locally. You might want to check it out and then try it out. Do understand you'll probably need 20 to 30 GB locally to actually run all of the models and set it up, right? So that might be something you might want to check, right? So once you run it locally, you should be able to get something like this, right? I am running it on the cloud. This is called jarvislabs.ai. So if you look at right? If you want to go check out Jarvis Labs, they basically help you rent GPUs and run like notebooks, Jupyter notebooks, or if you want to run automatic 111 or Comfy UI, all of these things, you can just go here and run it. I pay for this. It's better than investing so many thousands of dollars into a heavy graphics card. I run it on the cloud right now. There are free collab options also that you can use for running, which I'm not getting into, but I'll probably share it later in the community. Right. So this is what I'm using. Right. So a couple of things to kind of explain the UI over here, because I know there might be too many controls over here. We'll get to each one of this during the session today. One of the first things you probably have to set up while running Stable Diffusion locally is to probably set up a few extensions when required. So you should be able to search a lot of extensions from here. And then, for example, if I need something like control net, right, I should be able to load it or install it from here and then set it up for people. And after that, I can just restart or install and apply it, right? So this is your main page, right? And you have a lot of the models here which you want to run. This is there's something called a core model or a checkpoint, which is basically the main trained model. This is generally between 3 GB, can go up to 7 GB in size, depending on the model that you're looking at, right? This is where you define your prompt, right? You can define your prompt over here. There's something called negative prompt. I'll come to all of this, right? You can ignore some of these information right now. But if I were to type in something like a race car, right? And if I were to click generate, you can see that it's creating like an image for you, right? So this is able to create an image for you. Now, if you try creating again, you actually get the same image again. This is because you're not randomizing your data, or you're not randomizing your seed. So there's something called a seed, which is used to kind of define your output. So if I change my seed, let's say to seed 1, and I generate, it creates a different output. So if you're trying to experiment and run things, people generally try to use a randomization, which is -1 here. So every time you generate, it gives you a different output, right? And please note, I'm able to do this fast because like we are running a 16 GB system over here, I think, right? We have a 16 GB graphic card running here, which is why it's probably faster. But this is an example of how you can change that seed value and then get different output. But if I go back to now 1 and then generate, you can see that I get the same output again. So if you want to control the same image and then see how the different steps work on it, or you want to change the configuration, controlling the seed might be a very useful thing. All right. So yeah, so what we have basically looked at is some of these basic entry points here. Let me now kind of explain to you there's something called clip, right? Which is basically it's called contrastive language image pre-training, right? So OpenAI, for example, has a clip which is used for understanding what is in the image. Now, if you have used ChatGPT and probably have a vision model, you can upload an image and it actually describes what is on the image, right? So you're able to do that also with Stable Diffusion. So if you go to interrogator, I can take an image of this, right? And I can create what this image or the description of the image from this. So if you give this takes a little more time because it is processing heavily to actually get all the output. So it does take a lot more time than other outputs, and you can choose between best, fast, classic, and negative. If you want a faster one, I would recommend going through the fast one. Generally, I've seen this takes around 30 seconds to 1 minute. Faster one is probably better, I think, that way. But let's give it a second. Yeah, so you can see this is a close-up bunch of white flowers. This is probably describing the kind of image. That's an autofocus. It says hydrangeas. I'm assuming this is the flower. Yeah, so this seems like the flower. What it is, I don't know what it is, but the system is able to use OpenAI's model and tell me what the system sees in the image. And this is again because of the pre-training that has been done. Right, so this is called clip, and you're able, this kind of creates that relationship between text and images, right? How does an image, a text create an image? How are you able to see what is on an image? And this relation is kind of being generated using this clip. So there, if you, in the future, you may have like clip-based search also. You can search on a video also maybe in the future, right? Clip may play a role in that in the future. There is a great paper also by OpenAI for this. You can actually go and read this. They have a very nice detailed model of how this actually works. It's quite an interesting read. Recommend later if you have time on the weekend. So we have kind of explained how you can use clips. So this is sometimes if you want to understand what a prompt, what can I use for a prompt, right? You see some image online, you want to say, you know, how did this person create this image on using AI? You can try to feed that into your model and then try to use clip to kind of retrieve some of the prompts out of it. All right, this is my own photo, and you can see that it's able to determine my age correctly. It's able to determine that I'm celebrating my birthday. It's also able to determine this table and the food on it, right? It's quite interesting how it's able to determine all of this information through it, right? So we have gone through basically the same thing about creating an image. So we gave a prompt earlier, right? We are able to give a race car as an input, and then you're able to see the output in this manner, right? And we spoke about the seed value also over here, which is controlling what that output. So in case you want to have a specific image you want to work with and then improve on it or change that, you get to work with the seed over here. So now the next question for you is like, how do I get a good image out? So you need to understand the anatomy of a prompt. If you've worked with any ChatGPT or other systems also, you'll probably understand there is a way to prompt, and people call it prompt engineering, right? And we give different information into it. So it could be a subject, could be a details, and then could be an art style. So you can see if you are able to start like give a specific description around it, let's say a race car, right? Maybe details could be like, oh, there's a stadium, there's a race going on, or it's an empty road. What kind of a style do you want? Like a painting? Do you want a real life? All of this can kind of describe and help the system understand what exactly you're looking for. Right? So there's a question, what would happen if you feed the same output back from the clip to the, great question. So you may not get the same output, of course, because you're probably not trained with that data. But if you were to try it out, right, and I'm just going to paste that same text here, you may get something on those lines. It may not be the same, but on those similar lines. So you can see you're able to get or create similar images. This is a question by Manish. So if you're able to add a few more prompts on it, you can see some of the information coming back and kind of giving you an idea how to ask different information, right? You may have to obviously change some of the prompts because it may not be 100% accurate to what you want or what you will get out of it. Okay, so now there are different things that you can work with while creating a prompt. Just give me a second. Yeah, so I'm just going to take out an example of, like, I have some prompts already kind of written out so that you don't have to like, we won't be writing it out too much, or we don't have to figure out what a prompt should be. These are some prompts I've already explored earlier. Right, so if I go ahead and generate this, right, you get a certain output on this. So what I'm trying to do over here is kind of give a certain set of information into it and then get a certain output out of it. So you can, yeah, so here you can see a few more controls in addition to this. Is something called batch count. Okay, so now let's say you would have probably, if you've seen Midjourney or other platforms out there, they also tend to create multiple images out of it, and then you get to choose which one you want to work with. So you can actually control that using this thing called batch count. And if you now generate this, it creates multiple seed values and then generate. So you can see this is creating 4 images for you, but with different seeds basically. So the seed is actually getting incremented by 1 every time, right? If you put 10, let's say, it's going to create a different set of images for you. Does that make sense? Yeah. So let me go back and type out another prompt here, right? So this is an example of like a person walking with a dog, and on a city street, some basic information about a lady walking through it. Now, there's one more thing. Sometimes when you work with prompts, you also have something called a weightage. A weightage is a way to kind of give emphasis to a certain prompt or a certain text. So let's say you use this dog and you write 0.5 or let's say 1.5. The emphasis on the dog increases on the prompt. So you can actually do that over here and say 1.5, and when you click on generate, you will get more emphasis on the dogs also here. So you can see it tries to create, in this case here, you can see there's like 2 dogs being generated. Right, so you're able to control this behavior with the help of adding a small weight to your embedding or your prompt itself. So if you use 0.5, you can see the emphasis on dog is kind of reduced, and you can see similar images out there, but the dog is kind of missing. Right, so this is what text weights do. So in case you do see like random numbers within the prompt, it's essentially going to be this. So we already kind of spoke about the batch size earlier, number of outputs you can get from each image, right? So what I also want to touch upon over here is when you're working with these prompts, right? There's something called embedding. So these prompts are actually just creating these or looking up these embeddings onto your system. So let's say you are working with Stable Diffusion. Generally, sometimes what happens is you don't get the best output, right? Or you want to get a certain output maybe with your own data, right? So there's something called training of your own images that you can use with AI models. So this is a good point to talk about, because you may ask, hey, I have OpenAI or ChatGPT or DALI or other systems like Midjourney. Why should I really care about Stable Diffusion when it gives me so many, like, does it really matter? So if you're ever going to, like, in the future want to now train your own data, right, and then work with that, it makes sense to kind of understand these systems, because you can add or train your own textual inversions into your systems, right? I'm not getting into details of this. This slide is actually from another member on the community. So I've given his YouTube link also here. He's explained all the different ways of training your data for Stable Diffusion. So a classic way is something called Dream Booth. This is quite an expensive process, but like it's actually like creating the entire model itself again. So it's going to be like heavy in size that you have to deal with, right? So mostly like it's going to take a while to actually work with Dream Booth. The next is textual inversion. So what it kind of does is that it kind of goes and updates certain embeddings on your model itself, and then when the Stable Diffusion model is comparing that image, the denoising image, right, it will now check the loss function against this diffusion model, and that mode of checking that, hey, should I punish this image or should I make it, should I reward the model or should I punish it, it happens by checking against these textual inversion or this custom data that you have inputted, right? So it kind of changes some of the information here, and then you're able to work on it. So this is one way that you can work with. There are other models out there. There is something called LoRa that you can work with. We'll touch upon LoRa also later. So these are basically how like a text is converted to a token, and then this is basically stored in a vector embedding, and then from there you're able to now map it to certain images. Say that, hey, this is probably for a clock, right? And then you noise that sample, and then when you request for an output, it's using this to kind of create that final output. It's okay if you don't understand too much on the background here. That's not a problem. The intent of the workshop or this session is not for that. So there are many places where you can go and search for certain models out there. So this is just an example. There are many other ones out there. So you can go to Hugging Face, which is quite a popular place for the community to go actually search things. So if you want embeddings, you can actually just search here, right? So all these data sets for different types of ML models, you can actually get data sets and other stuff. You can also get this at Civit AI, which is quite popular. They recently raised a funding of $5 million. So if you want certain models here and you want to get character style and all of that, you can get it from Civit AI also. So this what you're seeing here is also actually an example of from Civit AI, right? So this is a celebrity singer, Avril Lavigne. We are just going to show a simple example of how a TI can affect your final output, right? So how do you actually set up a TI? Well, there is a PT file or a safe tensor. PT, I think, stands for Python tensor or Python torch files, I think. And these can be imported into a folder called embeddings, which is in your Stable Diffusion. So if I go and open my system, right? So you can see, so you can see these are all the embeddings that I've already uploaded into my system, right? So you can actually now apply that into your UI also, or in your image generation. So where do you see it? In your stable diffusion or in your automatic 1111, you should be able to see that inside this textual inversion. This is where your embeddings are. So how is this going to be really helpful? Well, there are positive embeddings and there are negative embeddings, right? What I mean by this is sometimes you don't want something to happen. You want like your AI systems are quite bad at creating fingers, some type of image. So this is an example of like Avril Lavigne basically singing in a stage cinematic lights. This doesn't look too great, to be honest, because it doesn't probably not the best prompt out there. Right, it's probably not the best prompt out there, and the output that you're getting out of it is also probably not the best. So what can you do over here? Well, let me go and so let me go create this. Right, we may not get the same output because I don't think I have saved the seed on it. Right, so we get this as an output, right? So this looks okay, but if you want to now go, instead of changing this here, if I go and add an embedding over here, right? You don't need to remember your embeddings, but you just go to textual immersion, click on this, it will copy it over for you. So if you're able to now use this instead, you should get a little better output in your images. Right, and you can see that this kind of creates a better output based on the character that you have, which is Avril Lavigne, right? And this is the interesting part about working with Stable Diffusion or any other tools, that you get to get that control in your image generation by training your own custom data. And since working with TI or LoRa is not very expensive, you can still train it, and it won't be in a large data set out there. So you don't need a heavy system to actually train this. So you're able to get customized output over here, right? And if you change the seed, basically you'll get different output, but you can see how much of a difference this is creating. So there are a set of negative prompts also you can apply. So generally, like you want to remove certain things from the system, right? So let's say deformed characters, all of that you want to maybe remove, you can actually add it to your negative prompts, right? And this also ends up affecting your final output in a little manner. So there are a few more things, like for example, bad hands, some EC negative, deep negative, very bad negative. So if I can go and add all of this, right, it can work on this and give you like a better output. So these are negative textual inversions, which you can download off Civit AI or different areas, and it'll give you much better output. So instead of you going and training everything on your own or figuring out what those prompts are, these embeddings already have some information which it is trained on. So you can see there's a little better quality, but you can still see the eyes are still a bit deformed. It's not very clear and all of that, right? So that of course will take a lot more customization. You got to figure out your a lot of like configuration to actually get there, right? But this is an example of how you can use textual inversion into your systems to get better outputs. Make sense? So this is an example of how this image became better just because I was using a embedding on it. Right, so here's a set of examples also again, same set of data, and you're able to get this as an output. Yeah, so you can see when you remove, add these like base, you can see it's a little blurry here and it's not very clear, but you can see this is a much better output that's coming because of it. So you're able to add a lot of this information using these inputs, right? So another point also I'll probably touch upon is, so on the top left, right, you'll see something called stable diffusion checkpoint. So this is also like all the models that you can actually use with. So there are plenty of models you can start with. Something with stable diffusion or stability recently released is SDXL. So these are newer versions or new latest models which have come out. So there might be some things which are good on it, some things which are probably, like some LoRa's are probably not trained on it yet. The community is still trying to catch up with all the new changes that's happening. But depending on what you want, you might want to change your checkpoint also. So the same, so if I change my base model, you might get a very different output also here. Right, and this might not come out the way we expect, but you can basically change this to get your final outputs. And this embedding might also not be very valid. So let me change this to the original one. Yeah. So you can see the base model is probably gonna give you probably a little better output, but let's see. This is the SDXL 1.0. There's a few updates on this you can check online. Right, this is without the embedding though. Yeah, so TIs are nothing but embeddings itself, similar to your prompts, but you can add custom ones, but which go and override some certain areas, right? The next one is called LoRa or low rank adaptation. Quite a similar approach. The one difference here is that you want to train, let's say, a new concept, something which is a little outside of the trained model or outside of your base model. Then LoRa kind of makes sense. So again, this is from the same video which I've shown earlier. So instead of actually going and changing your embeddings, right, you can see earlier with TI, so it was kind of updating all those certain embeddings within your model. But with a LoRa, when you add, there are new weights being added to it. So and this doesn't directly come on the model. So it's a lot of current systems are actually working on custom LoRa. So a lot of organizations out there, what they end up doing is they create custom LoRa's privately, and then they use that to kind of train systems and get better outputs, right? So a lot of companies do this already. So it's basically a way to train stable diffusion models. And this is just an example. I've kept the link of where we got this image from, so you can actually check it out yourself. So there's an example of like how a Joker image could be generated here. But when you add or train it against a certain model, so let me show you the LoRa which is there. So this is a LoRa from the Joker, and what it works on is some of the data which is here. It's using this to train that person, right? And now there is some pieces of this or some information from this is actually being now reflected in this Joker here, right? So in case you want to now have character LoRa's or style LoRa's, you can actually use custom LoRa's for this. So you want to have the Joker itself, but a certain character, a certain actor, all of that you want to get influenced in the image, then LoRa's a great way to work with. So the same thing, you can also apply a certain style to it. So the first one is probably more anime style, but on the right side you can see it's a little more Arcane is a series or like a gaming series, which is so it has a specific unique style to it. So when you use that model and then a specific LoRa against it, you can see that it tries to create that as an output for you, right? And a lot of this also depends on the base model that you have. So it may be sometimes a little hard for you to replicate step by step or each of these outputs. So you'll have to figure out which of those models you're working with, and all those configurations becomes like a important part of your output. Right. Yeah, so I'm going to show an example of basically the same Joker itself. So let me yeah. And let's also go and update the base model. Basically, you can have different ones. I think I've tested this on Modern Disney earlier. So if I use this, and let's go and generate an image. So you can see this creates this kind of an output for you, right? Now, how do you get your LoRa to be influenced over here? Well, so once you download this, right, you'll have a safe tensor or a PT file, which you can go and place within your models folder, which has a LoRa folder on it. So you can see all the different LoRa's that we have added over here, and this is accessible. Once you do this, this is accessible in your LoRa subtab, right? So you can see you can apply a Joker over here. So you can see there's an angle bracket, and then it says LoRa, and then like there's a colon, there's a Joker, which is essentially the file name, and you can add the weightage over there. I'll come to the weightage in a bit. Now, if I go and now create this, you should hopefully see that LoRa getting affected into these output. So the seed is the same. We have put 0 here. So you can see how the LoRa is now affecting your output, right? Which gives you like a much higher quality or a specific quality based on that. So this is like very, very useful for training your data to get that specific output that you're looking for, right? Let's say you train a character and you want it in different images or different places. This really helps you with that, right? Make sense? Now, some of the challenge around LoRa's is that, so what you see here is this weightage, right? 1 over here. So there are times that you probably work with multiple LoRa's. The thing you got to understand about LoRa's is, let's say you have, I'm just going to copy this, right? Let's say you have another style here, and then you have style LoRa 3 or something. You cannot work with this because there's 1, 1, 1. So one of the rules or one of the things you got to guidelines around using LoRa's is that this has to, the sum of all the LoRa should be equal to 1, right? So when you apply multiple LoRa's, you got to ensure that 0.5, 0.3, 0.2, it's actually summing up to 1, right? So that might be something that might affect your outputs. So even the same thing, if I just move it to a 0.5, right, from a 1, there might be a slight change, or the output, like what output you get might be affected over there. So let's see that again. Right, so this is probably a little lesser. If I put 0.1, right, maybe hopefully we can see a little the impact being lesser and lesser out of it. So now you can see the effect of the LoRa, what you had compared to earlier, versus now is a little different, right? What you just saw earlier, the effect of the LoRa is not as much. So this is how you can control the weightage of the LoRa, right? And if I had to put this side by side, let me put this side by side. Right, I think this was at 1. What you saw, this was at 1, right? This was at 0.5. Not that much of a change though, I think. And this was at 0.1. Right, so depending on what output you want to probably play around with this number also to get that final output, right? There are a few other LoRa's which we do have. Not sure. So one of the things with LoRa's also is that multiple LoRa's may not work together also very well, depending on the data that is being trained. So it does affect the output with each other. So you got to do some test between each other to actually see if it works out. I'm gonna try a few more LoRa's that we have. These are for better diffusion, like it gives you, like, removes a bit of noise and stuff. So let me see how the output is going to be over here. So if you compare this to these here, there's probably slight differences. Probably we may not be able to directly point out to some of it, but I think some of the noise is probably a little lesser compared to this, right? So this is again something you'll have to test out and then see how it's going to affect your final output, right? So LoRa is a great way to kind of work with and get your specific output. So you can have a style LoRa. You have so a style can define your, let's say you want it in anime, you want it in different areas. You can try that, and then you have a certain character which is trained on certain areas. You can have a human trained on something, but you can end up getting an anime out of it. So there's a question, do unrelated negative prompts have an effect on the image? Possibly, yes. It could have, not always, but it could have some effect, slight, minor, depending on what those prompts are. Yes, so it can have, yes. Okay. So this was an example of what your image without a LoRa was, and you can see with the LoRa how the same output is coming out, right? There's a huge difference out there, and you're able to now even understand, hey, this is a person that I can recognize. This is a person, I think Heath Ledger. I could be wrong. I'm not great with celebrity names. Yeah. Cool. So we have gone through a couple of things so far, which is we have understood how to work with prompts. We have understood what consists of a prompt. We have looked at something called TI is a way of training some data. We have looked at LoRa, which is another great way of training data. I think as of now, a lot of people use LoRa's in many places, and there are many ways to train it quite fast also. In addition to this, we kind of play around with the different UI and figuring out what we can work on top of it. Now, next thing I want to probably look into is something called in-painting. I don't know how many of you have probably seen these cool videos of people adding objects to your images or removing something out of it, like a magic eraser or different things. So it works on something called in-painting. So what actually happens here is this is an image to image generation. So you actually have a certain image and you're selecting part of that image to actually give you a different output. right? So we'll probably speed up a little bit more than what we wanted to, because I do have a lot more to cover. We're just like not even halfway through. So let me take an example of, so let's go take out. So I think this is something which we had seen earlier. I do have a seed image for this. I'm gonna probably move this to 1. I'm gonna change the model to a realistic vision. I think this is what I used earlier also. So once that is loaded, I can generate the output. Yeah. So this was something which I had generated earlier, right? Now you can actually control something within this. Now let's say you see this icon over here, which is basically to send image to an image to image tab. So now I can do something called in painting, which is actually I can control this image and get an output out of it, right? So I can change my brush size over here, something a little larger, right? And I can select a part of my image over here, right? And I can define some of the specifics around it. So I can say in paint only the masked area, because you want it to be specific around that. What else? The original is fine. Yep. So let's go and now kind of change this prompt here, saying that I can add a majestic dog, Siberian husky, angry. Now if I do this, I think this should add, you can see there's a small dog added there, although it doesn't seem like it's very clear. So you can go and make this a bit random here, the seed, just to get that different output over here. If you're not able to get this output, we can also increase the blur a little bit and increase the size, right? This helps give it a little more context around the entire image around it. Okay. Let me check this out. Yeah, this is probably have to change a few of the configuration. Okay, so you can see the dog coming up in the system, but it's definitely not, it's merging into the person because we have selected that as the body also, right? So it's definitely not perfect. Let me try if I can see something a little more simpler. Oops. Let's go to this, send this back to in painting. Yep. And let's see if I can add something over here. right? And I can probably reduce the masked model a little bit, and you can now see that it's showing you a bit of the a moon over there. So this is a small example of how you can do in painting on top of your image to get that better output. I think I think this is probably why it was not working. So when you're working in painting, it's better to use a different model for it. I think this is what I probably did not set up. So let me try that again with the SDEV 1.5 in painting model. So if I generate now, oops. Yeah, let's try that again. I think the configuration should be a little better now. Okay, it is affecting it, but not in the right way that we wanted. But I'll show you some of the examples we have done earlier, right? So this is the idea of in painting over here. We were able to add a dog just by like selecting that area, and then we were able to add a Siberian Husky there. Similar to that, we were able to add a moon in this manner here. So I guess something in the configuration probably messed up. I'll have a look into it later. Right. So this is we're going to move to the next piece, which is something called control net, and I think this is the most exciting part about working with Stable Diffusion. I had a lot of fun learning control net and working with it. There's a lot of stuff in control net which actually gives you a lot of crazy configuration or probably power to getting your right output, right? So a lot of interesting stuff here. So why is control net important or helpful? Because I think in current structure you get a lot more, like the name suggests, right? It's control. So it's you get more control over your neural nets, and you're able to define what output you want much clearer. So this is just an example of how you're able to give a certain reference image, right? You have an input image, and you can use different models to define behavior of it. For example, in the first one here, what you see over here is something called Canny Edge Detector. So Canny is like a model which helps you detect edges in your images. Now, instead of giving like a blank noise image, you feed this along with your noise or part of your noise. Now, when you're denoising, you already have a reference image. So when you try to create that final output, right, that text embedding that we're giving, it tries to match with this initial image that we have. So it has different models there. On the right side top, you see something called a pose, open pose. So you can actually, instead of using the edges, you can visualize the pose of a human being and then kind of control that. So you can actually go and edit it also, which is quite interesting. And then you get the exact output based on that. So there are plenty of models on ControlNet that you can download, right? So I've just given you some examples over there, and it uses different things for different outputs you want. All right, so you can go check it out on ControlNet. How you should be able to set it up again is through this extension. We already have ControlNet, I think, added. Do we have it? Yeah, we have it added. Yeah, so you can see the SD Web UI control net. This is what we're using here. So what happens here is that you will see there is a small tab called control net over here. So this is where you can actually define that behavior or give that information to it. Right. So this is an example of how you can take a drawing, like a child's drawing, right? And you can actually retrieve the edges out of it. And then you can say, hey, I want a unicorn coming out of it. And you can see it transforms itself into a different image completely. So imagine like maybe the next generation of kids. So if you remember those tablets where kids sit and scribble like simple diagrams or drawings, right? It could be in a way that this gets transformed into something of their imaginations, which helps them like draw from a very simple image to actually final output. So the same line art, you can also see another example here, right? You're able to get an apple out of it in this manner. So the input is just a simple line art of the apple, and you're able to get a final output in this manner. So let's try that. I think I have this apple here. Okay, so I can't find it, so just give me a second. Yeah, so I'm just putting a simple apple over here, right? So what we can use over here is something called line art, right? I think line art standard, right? So you can go to allow preview and enable for you to like see what that output is going to be. And then if you click on this button here, this is the line that is extracting the black and white, right? So the model now uses this as a reference. So I can go also now change the model which I want to work with, which is right. Do understand you have to do the same steps here to actually get control net working. Is you have to go and get all of your models added into this, right? You have control net here. You need to go add all of this here. Once you do this, you will be able to access it. So now if I go change this to like a ripe apple with glossy and let's go add right, and let's see if something else we need to do. Yeah, so let's see what the output is going to come out. Right, so you can see that just from a simple image you're able to get this. Do note the start drawing is I think coming because of the image itself. You can change or control that. If you have a better image as base drawing, you can remove that, I guess. Right, but you can see how you're able to now just take a simple line art and then create a crazy image out of it, right? And there's a lot of different types of stuff that you can do with when you're working with control net. So this is one example of working with line art, right? This is quite interesting, something called open pose. Now let's go and change this to open pose here. There are different models you can get out of this, which is a full just a general open post. Different things you can use here. All right, I'm going to use a different image here, and yeah, I'm going to use the same image that we have used here. And if I preview this or process this, you can see that it creates this model for you. It creates this like a skeletal frame of the person, saying that this is how the person's standing. So this is being used to kind of define what your output should be. So now if I go back and change this back to this previous prompt, right? Now when you try to generate it, you will have the final entity coming out with that pose, right? Although this is cropping it, I think, let me see if I just do a simple resize. So you can see that you're able to now control what that person's looking like or how the post should be just by simply manipulating this post. And now the interesting part is you can actually go and edit this. You have an editor here, right? And if you go and change this, right? And if you say that, hey, this is how my person should be looking like, right? And I send this to the user, and now I click on generate. You can see that we have not changed the seed here. It's, I think, the same, right? We have the seed as the same. You can see that the output is now based on the post which I've inputted. So it gives you complete control of what you want to achieve in that image. And this is, I think, something very, very interesting to work with. I had a lot of fun figuring this out and actually working on it. So this is just some examples of how you are able to change and create different images out of it. Right. So we were able to edit a post and kind of change things on this and then get different outputs on that. Right. So this is, and you can actually do this for your own images, right? You can actually define the pose you want and then get that out of it. So this is a similar character. We used a different image for it, right? Instead of this, let's go and set up this image here, right? And if I use this, you can see the output over here. Yeah. So if you just change around your seed data, you should be able to get different outputs, something you want to try out. So when you're experimenting, do try out different seeds also. But if you want that same person, and when you found that could fit, you could always fix on the seed and then try to play around with it. Right? Cool. So this is my own photo which I've tried with, right? And I used this to kind of instead of like an open, like a full pose, you can actually have your own face pose also. So I'm going to change that to, do I still have the image? Yeah, let me use this. right? And let's use open face, right? So now when you're trying this, right, you can see that there is a facial structure, like you're actually even looking at if the person's smiling, their eyes, a lot more specifics around it, right? So you can now control how a person's emotion should be, like are they smiling, are they angry, are they shouting. All of these things is something that you can now control with. And if you go to edit also, right, you can actually like change some of these aspects also. So that's something which you now have control over with different types of poses, right? And if I change this to, let's say, Obama having dinner at the White House, right? So you can see that change you're able to control through this. So I don't know if this changes anything, but I don't know if this is for the eyes, so it could end up being bad. But let's see what the output comes out. Okay, not much of a change. So this is probably good. I mean, it's easier to have a picture taken and then changing it, but let's just see if you're able to update or get an update through this. Not too much of an update. I don't think it affected as much, right? One sec. Yeah, it's not affected it as much as I wanted it though. Okay, so this is another set of things that you can actually do with OpenPose, right? We're not spending too much time there. There are different models also that you can work with. So, for example, I've taken a small drawing of Wonder Woman out there, right? And I kind of, what I've done is there's something called a depth mapping, right? So, wanted to kind of create the same model that we used earlier. So instead of a man, I used a female here, and instead of me using this, we worked with a simple model like this, and we used a depth model here. The idea is that to kind of understand, like it creates like a depth of the person, of the body and all of that through this. So you can see it create that figure and that person's body out of it. So you can also observe that not much of the background is come. You can see the black area, right? So not much from the background is actually come from it. So which is a good thing, because if you want to remove the background and only kind of focus on the person, it's good to have or use this model. So if you're now going and generating the output here, right, you should have something which is quite close to this in this manner. Although this is quite, this also depends on your input image. If you have like a very, so the general expected image is a square, because all the data which is being trained is actually on a square. So recommended to kind of use that, but let me see if I can change this to resize and fill. Yeah, so the side gets filled in there. So you can see how this is now changing your output based on this. You can see that the background is kind of empty, so you get a control of what you want also there, right? So you can take an existing character out and then get a similar pose even to the details of the hair and all, right? So you can see here the hair is also coming out very similar to what we have here. So it makes sense on those levels, and you can see even the body armor, all of that is also actually taken into account over here. So which is quite interesting to work with. And you have an option of like controlling all of these. You can play around with this to kind of figure out how much you want it to affect over there. Right. So you also have something called control mode, where you say your prompt is more important versus the control net is more important. Generally, you have a balanced output, but if you want to play around with this, you can also do that, where you don't want the control net to be like affecting your output as much, as very strongly. So you can see here the hair, for example, is not as affected by control net, right? So this way you can try to play around and then see what is more important for you, and then kind of get that final out. Right. So this is another example of how you can use depth. Right. We have used there's another simple, like a normal depth also. Not getting into this, but it's also quite similar in nature. I think this is another interesting mode to use, something called MLSD, which is called mobile line segment detection. So this is quite useful for architecture images. You probably would have seen people taking up an image of a room and then kind of completely changing it with some new decor or new like paint and all of that, right? That's probably using MLSD. So I do have a simple castle over here, right? Not this. And if I take out, so if I go to segmentation or MLSD here, yeah, this is the MLSD. And if I create it, you can see it kind of creates this image here, but you kind of want to change sometimes the threshold also. So of figuring out what those lines are. So depending on your image, you might want to change this a little bit, because I wanted some more of the lines to be figured out. So you can play around with this data here, or if feed a better image also, right? And you can create different outputs here. So let me go out and take, let me go and change this prompt here. Of course, this is also another problem. We did not change this here. So let's go. That is probably why the images could have been a little better from what we saw earlier. So let's load the correct model there. Oops. Let's give it a second. Okay, there seems to be, let me quickly just check my system. There seems to be like a small issue. I'm just going to restart the system. Just give me a moment. This is going to take a couple of maybe like 30 seconds to a minute. Yep. So let me go and pull out those images, those prompts again. right? And let's go set up our control net again. So one of the things which I like, there are other systems like Comfy, for example. You can save configurations and keep it like loaded back again easily. Not too sure exactly how we do that in automatic. So let's go. Okay, MLSD. Let's run that. Let's change the model. Okay, we have that. This is still in painting there, but yeah, let's just see what the output is first. Yeah, so what you can see over here is the output is kind of generated with these walls in line, like you see these edges in your buildings, right? It kind of takes that as a reference, to build your final output. So now you can take different kinds of architecture and then do the same thing out of it. So let me try creating a new one. You can see it creates a similar output here, right? But you can see it's inspired from this initial image that we drew. Make sense? So you're able to kind of create this kind of an output just from simply feeding in a certain architecture design. So it could be like your room also, for example. It will take out the structural integrity out of the room, and then you can kind of modify it to a different output that you need, right? So these are some examples of what outputs you can actually generate out of it, which was using this as reference. Now, there is another system also called semantic segmentation. It's quite similar to your mobile line segmentation, but rather than like your edges, this uses like the colors around it. So if you see the output over here, you can see that it creates this kind of an output, right? So the base image is not the edges, it's those colors which are being used to generate it. So if I go ahead and generate an output out of this, it tries to conform to the segmented data that we have. Right. So you can see here, this is how it's trying to conform to that image and get you that final output over there. And if you try making a different one, you can see this is a random seed. Should have given me a different output. Yeah, it's still giving you like light differences in it, but you can now see how you're able to control that final output just by defining this specific here, right? You're able to get that like you can go take out any kind of architectural diagram and then kind of conform it to this. So it's very useful that way. You can see some of the other examples also that we have kind of made with the help of segmentation there, right? So I think this is primarily what I wanted to kind of cover over the session today, or over this small presentation or workshop kind of a manner. And again, what you should be looking at is that, hey, you understand some of these models, you understand what can you achieve out of these, out of Stable Diffusion, out of different models or different UIs out there, right? Stable Diffusion is, Automatic 111 is not the only one. You have something called Comfy UI, which is also over here, right? You can see you can generate an output over here. Let me see if this is actually loaded or not. So this is also another way to kind of train, like it's a different UI to work with it, but there are different ways to work with it. I for some reason, I'm not sure if this is, yeah, it should work now. So you can see it's moving to a green color here, and then you end up going and saving that image over there. Right, so give it a second. Yeah, you can see the progress over here, which is similar to how Stable Diffusion also saw. You saw the progress bar. That's basically it's trying to generate the image over there. And once it's done, it will create that final output for you. So it creates this kind of an output from you. So different tools out there for different kind of models, and a lot more control you can get out of it. But I think primarily today what we wanted to cover was how do you get started with Stable Diffusion, what is basically a fundamental understanding of it, and how you can go and use all of this, right? So if you want to have a basic summary, we looked at how to work with basic prompts. We looked at working with textual inversion. We looked at working with LoRa's. We understood like some small differences between it. We were looking at basically at different parts of control net. We were able to kind of see how different models were used for different outputs that you wanted to generate. And in all, you were kind of figuring out the ecosystem around Stable Diffusion and working around it, right? Because this, if you try to probably set it up the first time, there'll be a lot of unknowns. I think the first time I set it up, I was like super confused on what's happening here. So I think the idea was to kind of impart that knowledge where you have a basic understanding of it, right? Yeah, so if anyone has certain questions, we can probably pick up more. Lohit has been answering a few questions. Thanks, Lohit, for that. Great. So this was our first event. We probably will do offline events in the future also, but we want to just see how people react to it. I know there's 6 people left behind. Thank you for that. But yeah, we didn't market this a lot. This was like a last minute thing that we put up on social media. But thanks everyone for coming in, and hopefully you have a better understanding of Stable Diffusion. We'll probably do more sessions out there around deep learning and different things, not just like around LLMs, and probably more text-based stuff also. But we'll be taking more of these over the next maybe couple of months. Whenever we get some free time, we'll probably do on a Saturday or Sunday, and hopefully more of you can spread the word and send get more people added on to this. All right. So thanks everyone for joining in. I will disable this from my system. Okay, thank you, Varun.